Hi, this is Miss Afric here. Today we're going to be talking about graphing square root functions. Okay, if you take a look here, it says something about this thing called parent functions. I don't know how many of you guys have heard of that before. Parent functions are just kind of standard functions that we should know what they look like. So like if you look over here, y equals x squared. Remember, we learned about these way before winter break ever happened. That's a quadratic function, and we know that a quadratic function is a parabola. Alright, so any quadratic function we're given, we know the general shape should be a parabola. And y equals x squared is the parent function from which all the other quadratic functions are based off of. Okay, today we're going to talk about another parent function, and that's the square root function. Okay, so we're going to learn the shape of it, and then we're going to learn how to graph any other type of square root function. Okay, now this might seem kind of out of left field because we were just talking about inverses, but you're going to see how they do actually relate. Okay, in number 1 it says, graph the parent function y equals x squared only when x is greater than or equal to 0. Okay, for now don't worry about that, but I'll bring it up when it's important again. Okay, then it says find its inverse and graph that function. See, inverse, already coming up. Alright, to graph the parent function y equals x squared, I'm just going to make it easy on us, and I'm just going to make a table. Okay, if you ever don't know how to graph something, table's the way to go. So I'm going to do a y equals x squared table. Now, this is one part where it kind of comes into play. See how it said only when x is greater than or equal to 0. That means for my table, I only want to pick x values that are greater than or equal to 0. So I'll pick 0, 1, and 2, just to make it easy. Remember, with tables, you pick your x values, and then you plug it into your function to get the y values. So 0 squared is 0, 1 squared is 1, 2 squared is 4. And then I just plot those points, 0, 0, 1, 1, and 2, 4. And there's my graph. Alright, notice how I didn't keep going to make the full parabola. Because what they've done is they restricted our domain by saying only when x is greater than or equal to 0. We're only actually graphing half of that parabola. So this is the graph of y equals x squared only when x is greater than or equal to 0. Alright, so part 1 done. Let's take a look at part 2. Find its inverse and graph that function. Well, remember, we just got done talking about what it means to find an inverse. Right? In order to find the inverse of a function, we switch x and y, and then we solve for y. So let's do that. Switch x and y, so x equals y squared. And then to solve for y, I'm just going to take the square root of both sides. I'm just going to rewrite this, flip things around so that it's y equals the square root of x. Okay. Now, I'm sure every single one of you watching and listening was just dying right there that I didn't put a plus or minus, right? Why didn't we put a plus or minus? We always put a plus or minus when we take the square root of something, right? Why wouldn't we put it there? Well, it's actually because of this restriction right here. All right? By restricting the original function, y equals x squared, saying x has to be positive, we're saying that the input has to be greater than or equal to 0. Well, that means that when we talk about the inverse of it, inverse, so instead of input, now we're talking about the output, we're saying the output has to be greater than or equal to 0. So that's why we're not doing plus or minus, because we already know that it's going to be positive because of this restriction. Okay, so I've got my y equals square root of x. That's the inverse. Well, hey, what a coincidence. That's what we are talking about today, the square root function. Don't you love it how that happens? So we're going to go ahead and graph this function, y equals the square root of x. I'm going to graph it the same way we graphed the quadratic function, with a table. Okay, but it's actually going to be even easier this time, because remember, with inverses, the output of our original function is actually just the input of our inverse. So I can just plop those numbers down right there. And the input of our original function is just the output of our inverse function. Right, this is all stuff we covered yesterday when we talked about, or the last lesson when we talked about inverses. So let's see. Inputs become, whoops, our outputs, so 0, 1, and 2. And if you take a look at our function, we can see those points still work, right? The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So it does work. Now let's go ahead and graph this. 0, 0, 1, 1, 4, 2. there is the graph of our square root function. This is the graph of y equals the square root of x. Okay, now it doesn't really have a name like parabola, but I just kind of like to think of it as an arm sticking out. So whenever you think about the square root of function, think of it like an arm just sticking out. And I'm doing the motion now. You can't see it. My kids will see it in class, but I just think of it as an arm sticking out. Okay, now I don't want to have to graph y equals x squared every time I want to graph the square root function. So instead, we've got this general form that we go to help us graph the square root function. And that general form, you might notice it looks a little familiar, is a times the square root of x minus h plus k. So go ahead and jot that down real quick. What I want you to notice is this h and k thing. Does that look familiar at all? It should. It should kind of look like vertex form. Remember back when we talked about vertex form with quadratic functions? Alright, this is kind of similar, just instead of a quadratic, it's a square root. Okay, there's also one other little difference, and that is it's not the vertex, because the square root function actually doesn't have a vertex, because it's just kind of starts somewhere. Vertex, we think of it as kind of the point separating where the axis of symmetry is. Well, this doesn't really have a vertex. Instead, I like to call it the starting point. So for a square root function, the starting point, it's the same idea as the vertex in that it's the point h comma k. So it's the opposite of the number inside the square root that you're adding, and the same as the number that you're adding on the outside. Okay, so let's take a look at this in these next few examples. Okay, it says determine the starting point of the given function g of x. Well, in order to find the starting point, it's really not too difficult. Right, we've got an x-coordinate here, which is h, or a y-coordinate here, which is k. It's the number you're adding to x, so the number you're adding on the inside, comma, the number you're adding on the outside. So in this problem, I'm adding nothing on the inside, and I'm adding a negative 7 on the outside. So that means my starting point is going to be nothing, which is 0, comma, negative 7. Done. Not too bad, right? For number 2, it's the same idea. It's the number I'm adding inside, but wait, don't forget, it's always the opposite of that number inside. If you think you're going to forget that, make sure you make a note of it to yourself, like really big, star it. Remember, it's the opposite, because that's the big thing we forget. Okay, opposite of that number, and then it's the same as the number outside, which here is nothing. So the opposite of negative 4 is 4, nothing is 0, there's my starting point. Okay, let's skip number 3. You can go ahead and try that one on your own. It's not a trick question or anything. I think you can handle it. But number 4, let's take a look at that. All right, again, the number that's on the inside, but don't forget, it's the opposite of it, comma, the number that's on the outside. So here, it's the opposite of 2, which is negative 2, comma, 5. Okay, all right, well, let's take a look at actually graphing some of these. So flip your page over. You can see that I've already filled in some of these definitions. So go ahead, if you want to pause the video real quick, just so you can jot this in and still be paying attention to what I'm saying, feel free to do that. So pause, take a second, jot it down, make sure you get that whole definition because it is important. Okay, we haven't talked about domain and range in a while, so make sure you remind yourself what it is. Domain is a set of x values that make your function defined. And the range is the set of y values for which your function is defined. Okay, those are really important when it comes to square root functions because there are values that aren't defined for a square root function, and you'll see what I mean when we start this first one. Alright, for number 5, for these problems it says graph each equation and state its domain and range. Okay, what I like to do with these is I like to try and figure out my domain first. Now you can always save the domain till the end, but I just want to show you kind of what it means to find the domain. The range is a little easier to see from the graph, so I save that one for the end. But the domain I want to talk about real quick before we start on the graph. Okay, remember the domain are the x values that make this function defined. So if you think about like when x equals 0, well, if x equals 0, I have the square root of 0, which is 0, plus 3, which is 3. That's defined. Right? If x equals 4, I have the square root of 4, which is 2, plus 3, that's 5. So it's defined. Right? what if I had the square root of, like, -2? Right, the square root of -2, well, wait a second. Think back. I know it's been a while, but whenever we take the square root of a negative number, we end up with something called an imaginary number. And imaginary numbers mean that our function is not defined there. So we do not ever want to end up with imaginary numbers when it comes to these graphing problems. All right, so when we talk about the domain for the square root function, the domain are the x values. It ends up actually being that the domain are the x values that make whatever is underneath the radical positive. Okay, for square root functions, that's what our domain is. It's the x values that make what's underneath the radical positive. So here, if we take a look at this, the x is the only thing underneath our radical. So what would make that positive is if x was positive. So our domain is just going to be x must be positive, which means greater than or equal to 0. All right, so there's our domain. Okay, now again, I'm going to save the range for later. You'll see it's a lot easier to see it once you've graphed it. Okay, every time we graph these, the first thing I want you to do is find the starting point. It's always the easiest place to start. That's what we call the starting point. Okay, so starting point here, hopefully we can recognize it, is 0, 3. So that's the point where I'm going to start on my graph. And then after you've got the starting point, we're going to make it nice and easy for you. Make a table. All right, and then just figure out the rest of the graph. Okay, now don't forget this domain up here. X has to be greater than or equal to 0. So when I pick my x values, don't go picking, -7 or something. That wouldn't fit our domain. So I'm going to pick 1 first. Okay, square root of 1, that's just 1. Plus 3 is 4. So there's 1 point, 1, 4. Okay. Now what if I tried to pick x equals 2? Well, if I plugged it in, I'd have the square root of 2 plus 3. Well, square root of 2, that's not really a nice number. All right, I don't want to have to deal with decimals here. So instead of dealing with decimals, I'm just going to say, well, let's not pick 2. All right, let's pick nice numbers. So I know that the square root of 4 is a nice number, so let's try when x is 4. All right, square root of 4, that's going to be 2 plus 3, which is going to be 5. So there's another point, 4, 5. All right, and there's the graph of our square root function. Now, remember, we still got to get that range there, and the reason I graph before I find the range is you should kind of be able to see it a little clearer now. Remember, the range are the set of y values for which your function's defined. Well, if I look at this graph, this is the lowest y value it hits, and then it'll just keep going up from there. All right, so I know that my range, it starts when y is 3, and then it's everything above 3. That means that my range is y greater than or equal to 3. Right, this function will never go to where y is 2 or 1 or 0. It'll always stay where y is 3 or above. All right, and you can do the same thing with the domain. You could graph it and then see what it is. But I like to see the domain first to help me with my table over here. Okay, all right, let's try one more. If we've got time. I think we will. Number 6, we've got y equals 2 times the square root of x plus 4 minus 3. Okay, again, I'm going to start with my domain. Remember, the domain are the x values that make what's underneath your radical positive. So here I don't just have x underneath my radical, I have a whole expression, x plus 4. So it's whatever makes those numbers positive. So to figure that out, all I have to do is set that greater than or equal to 0, and then solve that inequality. Right? Subtract 4 from both sides. I've got x is greater than or equal to -4. So there's my domain. Okay. Now, my starting point, take a look at here. We got the opposite of positive 4, so that's -4. And then the same as the number outside, so that's -3. So I've got my starting point of -4, -3. I'm going to plot it right here. Okay. Now, from here, you would go ahead and make your table. All right. But what I want you to remember is you can use your calculator to make your table too. Okay, so since we're running out of time, I want you to try and finish this problem. All right, make that table. Use your calculator if you need to, but pick nice numbers. All right, and come to class with the rest of that problem finished. If you're in Miss Afric's class, don't forget to do your WSQ. Have a great night.